was on the board earlier.
Okay. What I want you to do is I want you to look at your calculator. Are you looking at the sine, cosine, and tangent buttons? Do you see how in blue above sine says sine with a -1?
You see that?
That is inverse sine. Above cosine in blue is inverse cosine. And above tangent is inverse tangent. Okay? Yes, you do. You see it.
No, I said I also see E, F, and G.
Yeah, we don't need to worry about those. Okay. So, yes. Do you remember? Just kidding. Okay. So that -1, that means inverse. Okay. So the inverse tangent is that tan with the -1. Okay. So what do we use the inverse for? So let's say the tangent of x equals 5/4. Okay? Cool story, bro. Okay? I have the tangent ratio, but I don't know what the angle is. That is what our inverse functions are for. Okay? If the tangent of x equals 5/4, then the inverse tangent of 5/4 is going to equal x. It's kind of like if we have multiplication, then we divide to get x by itself because that's the inverse operation. If we have something added to x, we subtract it over because that's the inverse operation. If our x is trapped inside the tangent, in order to undo it, we have to do the inverse tangent. So in your calculator, could you press second and then tangent? And that brings up the tan -1 and type in 5/4. 5 divided by 4? Okay, and you get 51.3 degrees. Okay? what do we say? 51.3 degrees is what your calculator tells you. As long as you're in degree mode. Yes. Okay, cool. Do you have a question or are you stretching? Okay. All right, so we're going to do the same thing. Okay? If we have a situation where we have the sine of y equals a ratio, okay? Well, if I want y by itself, I need to do the inverse of sine. So we're going to punch in our we need the inverse sine of 3/7 to give us the angle, okay? So in our calculator, we would press second, we would press sine, and that would bring up our inverse sine.
Yeah. Another thing to mention for is the inverse of sine and cosine. The input has to be less than 1.
You are very correct, okay? You will notice that this ratio always has to be less than 1 or it's not going to work. 25.4 degrees. Is that what you're getting in your calculator? Okay. Did you have a question?
The first one says you have to be less than 1, but it's 5/4.
He said sine and cosine.
Oh.
Tangent can be whatevs.
Alright.
Okay. Whatevs. Okay. Inverse cosine. Let's practice that one. Let's pretend that I have the cosine of z equals 4/9. Okay. Well, if I'm looking for an angle that's inside a cosine function, then we need to use the inverse cosine of the ratio in order to figure out that angle. So you would press second, you would press cosine in order to get our inverse cosine, and then you type in 4/9. What is it?
63.6. bigger instead of smaller?
Huh?
Inverse cosine makes the numbers bigger instead of smaller? Yeah. Because usually with sine, cosine, and tan, the numbers get smaller. When you put them in there, like this makes the numbers bigger.
So we are putting in a ratio and getting a angle as an answer. Okay? Okay, now, hey. We're gonna come back to the solve a right triangle momentarily, okay? Let's come down here where it says notes. We're gonna draw 3 different pictures, so don't draw too big, okay? So our first picture I want you to draw looks like this. Okay, you have this picture drawn.
Was that eagle backwards?
Just hold on. Okay. Augie, which side is 3 compared to our angle x? Okay, and what about 5? So what do we need to use? So the sine of our angle is opposite over hypotenuse. So notice how I'm still setting up the sine of our angle equals opposite over hypotenuse. But since the variable in question is inside of sine, then in our calculator, we need to type in the inverse sine of 3/5. 36.9 degrees. And it is important that you put a degree symbol there since we're talking about a missing angle. Okay? Okay. The second triangle I want you to draw looks like this. I said we're doing 3.
Draw the second example. I took up too much space.
I said we're gonna do 3. So make sure you don't draw too big.
Wait, did he draw
oh
too
my
big?
goodness!
Wait, check if he drew too big.
He's like, Dad, I think I drew too big.
Is it too big?
You broke me
This should
over.
be a less exhausting day because there's half the people here.
You guys broke me
You
Well, you got
should
the
be
best
able to listen better because there's half the people
You
listening.
guys
Well,
broke me
well, you got the best
people.
people here,
Now we
so.
can't go outside.
Well,
It's only-
supposedly, but I don't know. We're not listening very
The
well.
other group would be the better group. We're all local.
That is it. Everyone is my favorite. Okay.
Just some people
So,
more than others.
which side is 7 compared to the angle we have?
Hypotenuse.
I guess that didn't really matter. It's always the hypotenuse. But what about 6? So we need to use the cosine because we have a.
Adjacent.
Wait, if the
Cozy.
oh, never mind.
Wait,
Cozy
so that means after
equals
this, I'm gonna use y equals 30 degrees. Zero.
So then,
That was like crazy.
the
Okay.
opposite, or not
So we can put in the inverse cosine of 6 over 7 into our calculator
Or calculate.
to get.
31. Just 31.
31.0027.
Alright. We don't have
Why did you put point?
Oh no, I was.
Okay. All right. Yes.
There seems to be an empty spot next to Cole.
Do it like that. Like, 2 seconds.
They're there in spirit. Okay.
No,
The
but like, no, like. That's not what I'm saying.
Why is Chase over there? Chase doesn't fit there.
I do say. Wait, Chase, why are you right here?
hey,
Are we serious?
Get me over this guy.
how about we use
Ollie.
what?
Oh, I thought we were gonna
How about we use all
Okay. C for Cole.
Yeah,
No, but like, you can put an
Use
O next
O
to it.
for all
because
of
it's
them.
actually
Ollie,
right there.
like we use
That's all.
Ollie.
Yeah, we use
Like right next to it because there's like a.
Let's use O for all.
O is not a good variable to use because it looks like a 0. Okay.
But can you put like a little like lines there?
Okay.
Yeah, like you could do the 0 into like the diagonal.
Nolan, which trig function makes sense for this triangle?
Tangent.
Okay. We have opposite and adjacent. So the tangent of C equals, what's my ratio? 10 over 8. Okay. So if I want to solve for C, we need to input the inverse tangent of 10 over 8.
51.1.1.3.
Wait, I knew that.
It's not a speed race.
Yeah, but if it was, it's about the motion of the.
Okay. Now, I would like you to come back up to the one we skipped. Solve a right triangle. If you see the instructions to solve a right triangle, that means you are going to find all of the missing sides and angles.
Oh, you'll not
All of the missing sides and all of the missing angles. Find every single thing.
Is that what we're gonna have to do for homework?
Ollie.
Okay, so it's like tan, cosine, and sine like a specific number. It's just like a super long, like.
Yeah.
Every degree has its own sine, cosine, and trig ratio. So, like, I can tell you that the sine of 30 degrees is always going to be 1/2.
You do not understand. I know.
No matter how big the triangle is, the sine ratio of 30 degrees is always 1/2. Put it in your calculator. Test me out.
I understand it now. Wait, so what
Weird.
is this? Sine of 30?
Wait, sine ratio.
The sine ratio of
actually
30
0.5.
degrees is always 1/2.
0.5.
The cosine is going to be radical 3 over 2, which is going to be like 0.7 something. Okay.
Is that a good question?
All right, now go to the next page. Do you see? Do you see where it says notes right here? Augie, we are going to fit 2 examples in this space. So what I'm going to do to help you out is I'm going to put a line here so you know that you don't need to cross that line.
Wait, sine 30 is 1/2, sine 90 is 1, and then sine 180 is 0?
Yeah.
But wait, if it's 0, then how do you do stuff with it?
Okay, hey, we're using right triangles right now. Why would 180 degrees ever be something that we have? Okay, now the 180 degrees and the 90 degrees, next year you will talk about those things. But today, I know. Try cosine, it'll be something different. Okay? You will worry about that next year in Algebra 2. Right now, I just want to focus on right triangles.
Okay.
Okay? Now, I want you to draw this right triangle right here.
You made it bad because it was a dumb
Guys,
question.
we are not gonna go. Homework.
Yeah, wasn't the point of today to not annoy me?
We're just
I wasn't
asking
trying to
good
annoy you.
questions.
No, we actually are asking good questions.
I know.
And it's about math.
No, I know. So you guys are asking wonderful questions and getting like really ahead of what we need to focus on.
Make no sense.
A lot of these things that you're talking about, you will explore in Algebra 2 and pre-calculus. Right now, we need the foundational skills, okay? So if I say, hey, solve the triangle, what's the easiest thing to find first?
Other angles.
The other angle is how many degrees?
90.
50. Austin, you got it. Good job.
Okay, 50 degrees, because I know if we have a right triangle, then these two acute angles should add to 90. Okay, so what I'm going to do is I'm going to go ahead and label this X, label this Y. Now you have some options. Okay, you can use the 40-degree angle or you can use the 50-degree angle. I don't care. Right now, I am going to use the 40-degree angle. Okay, so if I want to solve for X using 40 degrees, which trig function are we going to use?
And adjacent. Tangent.
The tangent of 40 degrees equals X over 20. Because we have the opposite and adjacent of 40 degrees.
So now we can do.
Okay, from here, I need everybody to listen. From here, you have a couple different options. Option number 1, use trig. Option number 2, use Pythagorean theorem. I think that the Pythagorean theorem is just slightly more work in my calculator than using trig. Okay? So what I'm going to do is I'm going to use the cosine of 40 degrees. And the ratio for the cosine of 40 degrees is 20 over y. I could use
Would
sine.
it just be 50 degrees and then it'd be.
That you could do that too, okay? I'm trying to use as much given information as possible, which is why I chose the 20-foot side instead of the 16.8-foot side, okay? Thank you, Conway.
Who is Scott?
It's like the 682 square root of 682.
And what is it?
This unit's a lot easier than the last one.
Yeah.
Okay.
Oh, wait, yeah, it was.
Okay. Are you talking about the first half of the chapter or the unit completely?
What was the first half to the last chapter?
Okay, draw this. Mike, are you saying this is easier than our trapezoid quadrilateral stuff?
What's the one we did last? It was like the.
Like the Pythagorean theorem and the 30, 60, 90, 45, 45?
Yeah.
Those so large.
Okay, that's still in this chapter, people.
What?
Yes.
Oh, bro.
Okay, now,
Why are you open?
I have 3 things I need to find. I need to find the third side and the 2 angles. How are we going to find the third side? Pythagorean theorem. So let's take 5 squared plus 6 squared equals our hypotenuse squared. Okay, now, I will tell you, if we are doing trigonometry, well, just kidding. Okay, what is h? Square root of 61?
7.8.
Okay. Now, how am I going to find angle X and angle Y? Ah, yeah, we're going to have to use the inverse of something. Okay, so let's first talk about angle X.
Wait,
What?
don't when you find it like X or Y though, you already know the other one? Because there's a 90-degree angle.
We do, so we only have to do trig one time, don't we? So we can say, okay, the tangent of X is what ratio?
5 over
5 over 6. So in your calculator, you can type in the inverse tangent of 5 over 6.
39.8.
And if x is 39.8,
51.2.
50.
That's I mentioned.
50.2.
Is it 50.2?
50.19.
What's the what for?
Never mind.
Okay, okay. Okay. Okay, you guys are making me happy today. Okay, so do you see where it says extra practice? Okay, so you are going to do the rest of page 270 and all of page 271.